Hello everyone, my name is Diksha and I am from the Bodhi Academy, and I am going to discuss some of the important chapters from 12th standard chemistry, and today I will discuss regarding the very important organic chapter, that is alcohols, phenols and ethers. So let us start with the nomenclature of the chapter. Okay. So in our lower classes, we already studied what is alcohols. Okay, the nomenclature of alcohols, how to write the names, how to write the structures. So in this chapter, we will study regarding the more compounds of alcohols. Along with alcohols, we will study about phenols and ethers. Okay, so alcohols, the general formula is ROH. Okay, so wherein R is the alkyl group and OH is the functional group that is responsible for the alcohol. Okay, now how we get this OH group here to attach to the R? If you remove hydrogen from the hydrocarbon and replace it with OH group, okay, if you remove this hydrogen and replace it with OH group, we will get ROH, okay, and that we call as a alcohol. Now depending on how many OH groups attached and which alkyl group is attached to that, we are having classification of alcohols. So let us move to the classification. So the very first is primary alcohol. Okay, so I will write a formula over here, CH3, CH2, OH. Okay, now here OH, that is the alcohol group, is attached to a carbon. Okay, and that carbon is further attached to one more carbon. So that's why this type of alcohol is termed as primary alcohol. Okay, then we will study about the secondary alcohol. So whenever we have this type of arrangement, CH3C, CH3, OH. Okay, so here what you can see is OH group is attached to the carbon and this carbon is further attached to two more carbons. So in this case it is called a secondary alcohol. Then we will go to the tertiary alcohol. So tertiary alcohol, now you all got some idea how to write the primary, secondary and tertiary alcohol according to the groups which are attached. Okay, so alcohol is attached to this carbon and this carbon is further attached to three more carbons. So that's why the name here will be tertiary alcohol. So these are the examples of primary, secondary and tertiary alcohol. Now why these all are important? Because the properties and some of the chemical reactions that we are going to study, these three things are very important over there to define the order, to define the reactivity. So that's why we have to first understand what is primary, secondary and tertiary alcohol. Okay, the next one is allylic alcohol. Okay, I will write the structure here. Okay, if this is alcohol, okay, now what you can see here, this OH is attached to this carbon, meaning this OH is directly attached to this carbon and this carbon is further attached to a double bonded carbon. Yeah, you all can see that these two are the double bonded carbons, 1 and 2. So alcohol attached to this carbon, the carbon is further attached to a double bonded carbon. So if you have this case, then it is termed as allylic alcohol. Okay, then we will see about vinylic alcohol. Now there is slight difference here in vinylic alcohol. Here alcohol which is attached to a carbon is itself double bonded. So here in first case what we have seen, the carbon is further attached to a double bonded carbon and here alcohol which is attached to a carbon is double bonded. Okay, now this form vinylic alcohol what we have written is not that stable and it is not that much preferred. Okay, so but this is one of the type of alcohols. Then next one is benzylic alcohol. Now what will be benzylic alcohol? Most of you all will think that benzylic alcohol will be alcohol attached to a benzene. But no, it is not true. So benzylic alcohol, we have to first write benzene ring and attached to that there will be one alkyl group and then OH group. So I will write a simple alkyl group here, that is CH2OH. Okay, so this is the example of benzylic alcohol. Now here I have written just one carbon or one alkyl group having one carbon. Now here you can take more carbons also, and we can write the benzylic alcohol in that manner. Okay, now this is the benzylic alcohol. Okay, now we have not started with the nomenclature that we will see now. So I have already written the types of alcohols, that is primary, secondary, tertiary. Now whatever structures I have written, let us give names to those structures, okay, or the formula. So primary alcohol I have written this. So let us first know about the general form. Okay, ROH, we call this as alcohol. So ROH, this is alkyl group and this is OH group. So according to IUPAC nomenclature, we give the name to this alcohol as alkanol. Okay, according to IUPAC nomenclature, this is called as alkanol, and according to the common name, we call it as alkyl alcohol. Okay, so this is called as alkyl alcohol. Now since we use the secondary suffix for alcohol as all the names of alcohol will end with "ol". Okay, so let us take the first example here, that is primary alcohol. Here we have taken alkyl group having 2 carbon. Okay, so what we call for that alkyl group having 2 carbon atoms, we call it as ethane. Okay, now what should be name here? Now we said that the name should end with "ol", that is the suffix of alcohol, and it will start with obviously the alkyl group. So the name will be, now this is ethane. Okay, so according to IUPAC name, the name of this will be ethanol. Okay, the name, IUPAC name will be ethanol. Now in this we call as ethane, right? ETHANE. Okay, now why we have not taken E here, there is one reason for that. Now since after E we have O, okay, so E and O both are vowels, so that's why 2 vowels shouldn't come together, that's why we have not taken the E. So that's why we have directly written ethanol. So whenever there is situation like this, you have to avoid writing the E. Okay, so the name of this will be ethanol according to IUPAC nomenclature. Now common names are also important, but not for all the compounds. Okay, so for some compounds you should remember the common names, because whenever they give in the exam about meaning the conversion, the reactions, that time they put the common names. So that time you must know to identify which compound it is. So that's why common name knowledge should be there, but IUPAC is more important. Okay. Now we will name this compound, that is secondary alcohol. Okay, before that, what will be the common name of primary alcohol, which is written here? The IUPAC name is ethanol. The common name of this will be, what we have seen, that common name should be written this way, alkyl alcohol. So this is ethane, no? So ethyl alcohol. So the name, common name will be ethyl alcohol. Now this is a secondary alcohol. Okay, in secondary alcohol what we see that 2 carbons are attached to this carbon, which is directly attached to OH group. Okay, so here the name of this will be, this is OH, CH and CH3. Now while writing IUPAC name, you all must have studied the rules, okay, in the first chapter and last year also. So here first we have to select the longest chain of carbon. So if we see here, this is the longest chain, 1, 2, there are 2 carbons. So we will number this carbon as 1, this carbon as 2. Okay, so whenever we have 2 carbon chain, what we name it as, we call it as ethane. But we have one more thing here, that is a substituent. And which substituent do we have? Methyl group. So, and it is numbered on the first carbon only. So the name of this will be methyl ethanol. Okay, we can call it as 1-methyl ethanol or methyl ethanol. It is no problem. Okay, so any way you can write methyl ethanol. Okay, then yeah. So why we have written methyl here? Because it acts as a substituent and the rest is this chain. Then we talk about tertiary alcohol. Here OH group is attached to this carbon and carbon is attached to further 3 more carbon. So here the name will be, first we have to select a longest chain. So if we talk about this horizontal chain, then we have only 2 carbons. But if we talk about vertical chain, we have 3 carbons. So the name of this will be, first we will write the numbers 1, 2 and 3. So at second position, second carbon, we have OH group and methyl group. So we will start with the methyl, 2-methyl. Now the longest chain is propane. So 2-methyl propane. Now alcohol is also on second carbon. So propane 2 ol. So 2-methyl propane 2 ol. This is the name of this alcohol. Okay. Now next is allylic alcohol. Allylic alcohol, we have written the example this. Here double bond is there. So name will slightly differ. Okay. So here how many carbons do we have? 1, 2, 3, 4 and yeah, there are 4 carbons. So I will start numbering from here. 1, 2, 3, 4. Okay. Now we will directly write the name because there is no substituent here. So since 4 carbons are there, the name will be, the prefix will be butane. Now here butane will come or butene will come. Now since there is double bond, butane will change to butene. So the name will be but. Now we have to see the number also of the carbon to which a double bond is attached. Okay. Now if double bond is attached to first carbon, then no need to write the number. But here double bond is attached to second carbon. Okay. So here how we have to write? But 2 in. Okay. But 2 in. Now why we are not writing E here? Same reason, because of the vowels. So but 2 in and alcohol is attached to first carbon. So but 2 in 1 ol, or you can write directly ol. So but 2 in 1 ol is the name of this compound. Next is vinylic alcohol. So here what will be the name? Since there are 3 carbons and we will start numbering from here 1, 2, 3. So first carbon is itself double bonded and to the first carbon only OH is attached. So the name will be prop, 3 carbons, so prop 1 in ol. Now I have not written 1 here, directly you can write the propinol or propinol you can write. Okay, so this is the name. Okay, so we have finished with the nomenclature till vinylic alcohol. Now this one is benzylic alcohol. Okay, now what will be the name here? See, we are using, what is the functional group here? OH. So the more priority will go to the OH group and not the benzene ring. Okay, so since more priority goes here, this chain is very important. So that's why we will start numbering from here. So since there is only 1 carbon, the number will be only on this carbon. And this will become the substituent. Okay, this group, phenyl group, will become the substituent. So what will be the name here? This will be 1-phenyl. Now there is number 1, so no need to write 1 also. So directly you can write phenyl methanol. Okay, so the name will be phenyl methanol. So the name, IUPAC name of this compound will be phenyl methanol. Now here are some examples. We will try naming this compounds. So the first one is this. So here we have a chain of 4 carbons and OH group attached to one of the carbon. So first we will start numbering. From where we will start numbering? From this side, left side or right side? If we number from left side, here it will be 1, 2, 3, 4, meaning the carbon to which OH group is attached will get the number 3. And if you number from here, this carbon will get the number 2. So what we have to see, the carbon to which OH is attached should get the lower number possible. Okay, so So that's why we have to number from here. 1, 2, 3, 4. Okay. Now to second group OH is attached, so we will directly start naming. So the name of this will be butane, 4 carbon, no? So butane 2 ol. Okay. Then we will see the second one. Here in the second example, along with OH, one more substituent is there, that is CH3. So here the name will be, now I have to start numbering from this carbon, 1, 2, 3 and 4. So here the name will be, longest chain is butane. So first the substituent will come, substituent is methyl. So at which carbon substituent is a third carbon? So it will be 3 methyl, longest chain is butane. So butane 2 ol. So this will be the name of the compound. Then we will try naming this compound. Okay, now here you all can see there is some, this is the complex level is little high. So here if you see the longest chain, we are having this chain 1, 2, 3, 4, 5 carbons attached to that OH group, and these 3 groups will act as a substituent. So this and this. So there are 3 substituents here. Okay. Now here one question comes that there are 3 substituents. So how to go about, how to write their name? Okay. So first chlorine will come or first methyl will come. So here we have to write first chlorine and then we have to go for methyl group. So the name will be, numbering we have to do here 1, 2, 3, 4, 5. So the name will be 4-chloro. Now 2 methyl group. So 2, 3 dimethyl. How many carbons are there? 1, 2, 3, 4, 5. So pentanol. So this will be the name of the compound. Okay, and the last one we will see here. Here there is double bond. We will start numbering 1, 2, 3, 4. This is substituent. This is also substituent. So the name will be, first we have to write about the substituent. So first bromo will come. So it will be 2 bromo, 3 methyl. How many carbons are there? 1, 2, 3, 4. So but. Now here double bond is there, no? So and at what carbon double bond is there? Second carbon. So but 2 in all. Okay, but 2 in all. Now 1 all you also can write, or all. Okay, so this is the name. So this is all about the alcohols. Next we will go to phenols. Now phenols is what? Whenever there is benzene ring and attached to that there is OH group, it is called as phenol. Okay. So there are no such classifications and all of phenol. We will just see the take some examples and see how to write the names of the phenol. Okay. So if I have a phenol, this is a phenol. Okay. And suppose if I take this CH3 group attached to that phenol, then what will be the name of this? Now CH3 group, this will act as a substituent. So the name will be, so this OH will get more priority. So numbering will start from here. So this will get 1 and this will get 2 number. So it will be 2-methyl phenol. Okay, 2-methyl phenol. Second example I will take OH and I will take CH3 and CH3. So here what will be the name? Now there are 2 methyl groups. So the name will be same way as we were doing in open chain structure. So 1, 2, 3, 4. It will be 2, 4 dimethyl phenol. 2,4 dimethyl phenol. Okay, now this is also called as ortho. Okay, orthomethyl phenol, because the methyl is present at the ortho position. Okay, so ortho parameta that we already you all must have studied. Okay, third example I will take, okay, wherein there are two OH groups. Okay, now here you all some of you all will say that the name of this will be diphenol or 1,2-diphenol, but the name of this is not diphenol, because what is phenol? Whenever benzene ring is with OH group, but here one benzene ring is there and two OH groups are there, so name will differ here. Okay, now we give priority to this OH groups. Okay, so the name will end obviously with all. Okay, so here what you have to do, benzene you have to write first. So here the name will go like this, benzene 1,2 diol. So this is 1 and this is 2. Benzene 1,2 diol. Next example we will see, wherein OH group is attached to first and fourth position. So here the name will be benzene 1,4 diol. So this is the way of naming the phenols. Okay. Now phenol, we don't have much examples here. We will directly move on to the ethers. Okay, ethers, some of you all must be not aware of the ethers, because alcohols, phenols, they are common, but ethers we have not studied much in our previous classes. So here we will study about the ethers. Now ethers is represented by this formula ROR, wherein both the R's are alkyl groups and O is the oxygen. Okay, so what name we are giving to ethers? Ethers are named like this. Now this is alkyl group, this is alkyl group. So IUPAC name is alkoxy alkane. Okay, alkoxy. Alkoxy means what? Alkyl group plus oxygen. So alkoxy and one alkane. Okay, now there are two types of ethers. One is symmetrical ethers, other is unsymmetrical ethers. Now what are symmetrical ethers? Symmetrical ethers are the ones wherein both the alkyl groups are same. So if I take example of CH3O CH3. Now here we can see both the groups are CH3 CH3, so same group. So here this is the example of symmetrical ether. Then next is unsymmetrical ether. Now here one R group will be different. So I will write this R group as R dash and this as R. So if both the R groups are different, then it is called as unsymmetrical ethers. So example here will be C2H5O CH3. Okay, so these are the examples of unsymmetrical ethers. Now how to name this ether? Here how to name the ethers? Okay. So as I said, alkoxyalkane is the IUPAC name given to ethers. So according to this name, what will be the name of this ether? Alkoxyalkane. So here methyl group, no? So the name will be methoxymethane. Okay. Now this is a simple ether, methoxymethane. The next, this will be, now here there are different groups, right? So since there are different groups, you will have one question that which group to write in this form and which group to write in this form. So here, according to IUPAC, the last name we are writing, this name we are writing suffix, that should be the longest chain, okay, alkyl chain with the more number of carbons. So here, if you see this, here there is only one carbon, here there are two carbons. So name will end with this name will start with this name. So the name of this will be methoxyethane. Okay, so the name of this will be methoxyethane. And here the common name of ethers are, so here if I take alkyl group in general, the common name will be dialkyl ether. Okay, so the common name is dialkyl ether, and here according to that the name will be dimethyl ether. Dimethyl Okay. Now here there are two groups now, so the name will differ here. So here you have ethyl and methyl group. So here according to alphabetical order you have to give the name. So first E comes or first M comes. Obviously first E will come. So the name will be ethyl, methyl, ether. This is according to the common name. Okay. So this is about ethers. Now these are some examples that we will solve. In first example, we can see that on left hand side there is CH3 group, on right hand side there is CH2, CH2, CH3, which is propane. Okay, so here according to IUPAC, the name will start with the alkyl group having less number of carbon. So here methyl is the one having less number of carbon and this is having more number of carbon. So the name will be methoxypropane. Then second one C6H5OCH3. Now what is C6H5? C6H5 meaning what? Benzene attached to some other group. Okay. So here which is having more carbons? Benzene is having more carbon and this is having less carbon. So the name will be methoxybenzene. So the name of this ether will be methoxybenzene. The next is this ether. Now here this is little complex. So how to name this one? Now here there are 3 carbons, here there are 2 carbons. So name will end obviously with this name. But here you have to consider this full chain. Okay. So either you have to start numbering from this carbon or this carbon. So if I start numbering here 1, 2, 3. Okay. Then the name of this will be, now this is the main chain and this is the second carbon. So to this second carbon, this group is attached, which is ethoxy group. The name will be 2-ethoxypropane. Okay, the name will be 2-ethoxypropane since this ethoxy group is attached to second carbon here. Because this we consider as a main chain, no? So that's why we have to number the chain. Okay. The next example is also little complex. So here we have C6H5 and this side we have CH2 6 times and CH3. So where will be the more carbons? In first case we are having 6 carbon and in this case we are having 6 plus 7 carbon. So obviously this side will be more carbons. So the name will start like this. Now this is benzene C6H5. What we call benzene in common, that is phenyl ring. Okay. So when we use benzene ring as a prefix, we don't use benzene, we use phenyl. Okay. So here according to that the name will be phenoxy. This is phenoxy and how many carbons? 6 plus 7. So phenoxyheptane. Okay, so it will be phenoxyheptane or 1-phenoxyheptane. Okay, so this is the way to write the names of the ethers. Okay, so with this we finish our nomenclature of alcohols, phenols and ethers. Okay, in next part I will be doing the preparations of alcohols and other reactions of alcohols. Okay, so for more such content, watch our videos.